to talk about resolution a little bit today. So let's say that we're trying to image something like this. It could be an inclusion or a pore, and the size of the feature we're trying to resolve is L. When you sample this space, your sampling size needs to be at least half of that feature size to see that that feature is there. And just terminology-wise for X-ray CT, the sampling size, L/2 in this case, is called the voxel resolution. And the smallest feature you can resolve is called the spatial resolution. So anyway, to see something, let's say 10 micron in size, your voxel resolution needs to be at least half of it, 5 microns in this case. And if you want to see the shape or size of the feature, then your voxel resolution needs to be a lot higher. And this is, I think, very intuitive, but there is mathematical background behind this. The fact that your sampling size needs to be less than half of the feature size, and it's called the Shannon Nyquist sampling theorem. And if you're interested in the mathematical background of this, I'm going to put a link to a really good YouTube video that explains this theory. Anyway, so for this on a video, what I would like to do is to take a look at an example image to get a feel of this. I'm going to close this and let's open this file. So this is a grayscale image, 128 by 128 pixels. The voxel resolution of this image is 1 micron. And we see those 3 types of stripes. Let's see how wide they are. Let's check their feature size. So those thick ones, I'm pressing Ctrl M by the way to get the measurement, is about 10 microns. And this medium one is about 5 microns. And those thin ones are about 2 microns. Because the voxel resolution is 1 micron, we can see that there are those stripes or lines that are 2 microns. That's double the voxel size. Now let's see what happens when we change the resolution of this image. So let me duplicate this so that we can keep the original image. So we have a copy of the first one. And I'm going to change the resolution of this image by downsizing it. So we're going to go from 128 to 32. So that's 1/4 of the original image, pixel size wise. And what this is, it's really tiny. So let me zoom in again. This image has 4 micron voxel size. The one on the left, original, is 1 micron, and the one on the right, we reduced, is 4 micron voxel size. And you can see that the wider stripes, they're still there, and you can probably put a ruler on it, roughly, and see that it's about 10 microns. But when it comes to 5 micron stripes, you can kind of see that they're there, but it's even difficult to count how many stripes are there. And when it comes to 2 micron stripes, you really cannot see them at all. And that is because the voxel resolution is 4 micron, which is greater than the 2 micron stripes, and it's about equal to the 5 micron stripes. So you can see that when the resolution goes down, you start to lose those features and you can't even see them. Now, you might think that, well, if you increase the contrast, even the resolution is low, you might be able to see them. Well, let's see if that's the case. So I'm going to close those and let's open this one. So this is essentially the same image, but the contrast is a lot higher than the original one we saw. Okay, so this is on 128 by 128, and again, I'm going to duplicate this. So this is a copy. And oops, we're going to reduce this image to, again, 32. So this is what happens. Even if the contrast is very, very high, still the same thing happens. we can see the wider stripes, no problem. 5-micron stripes, they're a little bit iffy, and 2-micron stripes, they completely disappear. So you really can't overcome the lack of resolution by increasing the contrast. So those are kind of theoretical examples, but as the last step, I'm going to show you an actual CT image. And let's compare those two. So those are CT cross-sections from heat insulator, which we really needed last week in Texas. Anyway, so the image on the left was collected at 1.06 micron voxel resolution, and the one on the right was collected at 0.26 micron voxel resolution. And then when you look at them, most of the thick walls in this foam material in the insulator can be seen in both cases. And those are, actually, let's take a look at one of them. So you have probably 2 or 3 pixels there. So if you put a ruler on it and take a measurement, so that's about 2.5 microns. So with a 1 micron resolution, you can see 2.5 micron thick wall, no problem. But when you compare those two images, some of the lines you see here, those very fine lines, they disappear in the 1 micron resolution image. The same thing here. You can see clearly there's a line here, but this is kind of blurred and it's almost disappearing. Let's take a look at one of them again to measure the size. So if you go there and look at this very, very fine line and see the thickness of it, and that's about 1 micron. You cannot really see the same feature here. So this is an example. When you use 1 micron resolution, you cannot see 1 micron thick wall. But if you use 0.26 micron resolution, you can see a very, very fine line. This is a cell wall in this case, that is about 1 micron. So this is something as a rule of thumb to keep in mind. If you want to see something, for example, 10 microns in size, your voxel resolution needs to be at least half of it, 5 microns in this example. Thank you for watching.